Welcome to lesson 2.2, multiplying monomials. So the first thing I want you to do is to remember that if we have a number, any number, times two things, that's going to be the exact same as if those two things came first squished up against, because that squished up against means multiply, and the order doesn't matter when we're multiplying. So I'm just going to write a little note here that the squished up against the bracket, whether it's at the beginning or at the end, it means multiply. So for the distributive property, we're going to take the term that multiplies the bracket, that's the thing outside of it, it needs to multiply every single term inside the bracket. So the term outside the bracket must multiply, and here's the key part here, every term, every single one, and that's why we're going to distribute it, every term inside the bracket. And I'm going to give two examples here. So example 1, if we have 10 bracket x minus 3m, that 10 out front needs to go and be distributed onto every single part inside the bracket. So that gives us 10 times x, which is 10x. Then 10 times minus 3 gives us minus 30 and m. And I think we mentioned in class, but in a term, the coefficient always comes first. So a little note that in a term, the coefficient, remember that's the number, the coefficient always comes first. So it's not x10. And it's just like, I don't know if there's a good rule for that. I sort of always say it's just like capitalizing the first letter in a name. It's sort of the way it's done. And everyone sort of agrees on it. Here's a second example. If I have minus 4e plus b, and my 10 comes afterwards, doesn't matter that it's afterward, it's still going to be distributed. It's just going to get distributed backwards. And every term inside needs to be multiplied by that 10. So I get minus 40e plus, the number out front of the b is 1, so I'll have 10 b's. So, question 1, expand and simplify. I'm going to have to distribute that negative symbol, and then I'm going to have to distribute that positive 5x. I'm going to make this bigger. So first I'll distribute that minus symbol, and I literally draw arrows all the time just to remind myself. So this means everything inside that first bracket is going to change plus to minus or minus to plus. So I'll get minus 2x minus 3y plus 5. And then for this plus 5, I'm going to have to multiply it on every single part of the second bracket. So I would get plus 10x minus 15y plus 30. So we've done the expanding, and now we have to do the simplifying. So that means that we're going to collect like terms. So we have a minus 2x and a plus 10x. That gives me 8x. Have a minus 3y and a minus 15y gives me minus 18y. And a plus 5 and a plus 30 gives me plus 35. So a reminder again that we always put the sign, like that minus 15y, we always put the this sign here goes with what? The term that comes after that. So just a reminder that the sign goes with the term after it. Okay, question 2. Let's see what we have to distribute. We have to distribute a 4 and a -2. So I'm going to distribute the 4 onto every part of that first bracket. So I'm going to multiply all of them. So 4x squared plus 4 times 2x is 8x. 4 times -3 is -12. For the second one, -2 is going to be distributed onto all of these. And I'm going to have to be careful because it's a minus. So minus 2x would be the first, x squared is the first one. Now -2 times plus 4y is -8y. -2 times -1 is +2. And now we need to collect like terms. So plus 4x squared minus 2x squared, because the sign goes with it. Let's just do all the combining. Plus 8x. Nothing else to combine it with. Here's a blue. Minus 12y, so looking for something else without letters. And +2. And that -8y is going to be by itself. So let's do the yellows first. 4x squared minus 2x squared is 2x squared. The 8x stays on its own. -12 in the blue plus 2 gives me -10. And I still got to remember to deal with this one, the -8y. And we've combined our like terms. Question 3. Write the area of the shaded rectangle in expanded form. So if we want to look at this, okay, if this whole big long thing is 3, to get the top of our shaded rectangle, if the whole big one is 3, I'd want to take away that x part. So the top part would be 3 minus x. And then because this is x, that would also be x. So area, as we know, is length times width, base or base times height. It's going to be x times 3 minus x. We're going to distribute. So x times 3 gives me 3x because the number comes first. X times minus x gives me minus x squared. And that's the area. But let's say we hadn't written it down that way. Let's say we wrote down that we wanted to do the base, the minus 3x times the height, which is x. Same thing, but this time we would backwards distribute. And every distributing is a multiply. We would end up in the same place. 3 times x is 3x minus x times x is x squared. Okay, multiplying monomials by monomials. Need you to remember that we're going to always do, so a monomial would have a number squished together with some letters, and it's going to be times another number squished together with some other letters. When we do the multiplying, we're always going to do the number times the number, and then it's going to be the letters times the letters. And we'll do some examples we might have to use with when we're dealing with the letters, we're going to have to use our exponent laws that we learned last unit. So if we're doing number times number, here's our first example. If we have 3m and it's multiplied by 5m squared, it means first I'm going to do number times number. 3 times 5, which is 15. And then we're going to do the letters times the letters. So m times m squared is really, I'm going to write it out just to be super explainy. M times m squared is really m to the 1 times m squared. So it's going to be m to the 1 plus 2, or it's going to be 15 to the m, 15m to the 3. Another way that I think about it, the first term had 1m. The second term had m squared, which is really 2m. So in total, we have 3m's. Here's a second example. Minus 7x squared times 4x to the 5. So number times number, minus 7 times 4 gives us minus 28. X squared times x5, 2 x's and 5 x's, we end up with 7 x's, or x7. So question 4, multiply. I'm going to zoom. Number times number, minus 3 times minus 2 gives me plus 6. A out front is a to the 1 times a2 inside gives me a to the power 3. b1 outside, b4 inside gives me b5 overall. x1 out front, no x inside, so just an x. And then I've got that leftover y on the inside as well. For question 5, number times number. So 4 times minus 2, 4 times minus 2 is minus 8. A squared, no a squared's in the next one, so it's just a squared. I mean, no a's in the next one, so it's just a squared. x3 with another x3, that's going to give me x6 in total. Z, I have a z squared, so that's going to give me z3 overall. And then I've got this y squared as well. And that's it. Question 6 wants us to find the area of this figure. So there's 2 different ways you can do it. I'm going to do it by splitting it into these shapes. So this one is a 2y here, and it's going to be the same length down here, so that's going to be 5y. I'm going to call this shape 1, shape 2, and shape 3. So the area of 1 is going to be 5y across here times 2y there. So it's going to equal 5y times 2y. Number times number gives me 10. Y times y gives me y squared. We're going to skip 2 for a little bit because it looks trickier. Area of 3 is going to be pretty much the exact same because it's going to be 5y times 2y equals 10y squared. We know that this whole big long thing, I'm going to pick a different color. This whole big long thing is 8y. But we've used up 2y here and 2y there. I'm just going to get rid of some of that blue first. Get rid of that blue, and might as well get rid of that. Okay. If that whole thing is 8y, I've used up 2y, and I've used up 2y here. So if I wanted to figure out how long that one is, I would have 4y left over. Because I did 8y minus 2y minus 2y. So this one here is 4y. So for area of 2, it's going to be 4y times, then we have to figure out how wide it is. So if it's 5y all the way across, and it's 3y here, that means that this part that's left over is going to be 5y minus 3y. So that means that this part here is equal to 2y. So it's going to be 4y times 2y. And overall, number times number gives us 8. Letter times letter, variable times variable gives us y squared. So now that we found all 3 sections, we want to find the area total. That's going to equal 1 plus 2 plus 3, all 3 of those areas. So that's 10y squared plus 10y, plus 8, my bad. 2 was 8y squared plus another 10y squared. They're all like terms, and when we combine them, we get 28y squared. Okay. Powers of monomials. So by powers of monomials, I mean if you have a term, and inside your term, you're going to have a number times some letters, right? Let's use the dot. Number times some letters, and they're squished together. So that's your one term inside. And then it's raised to an exponent. We need to make sure that we distribute that exponent onto every part of the term. So make sure to distribute the exponent onto every part. The numbers and every letter, every part of the term. And as an example, if we had 2m cubed x to the and the whole thing inside brackets to the 4th, that means I'm going to distribute that 4 onto the 2, onto the m cubed, and onto the 4. And this time I'm going to be raising it to the power of 4. So that would equal 2 to the 4, and then it's going to be m3 raised to the 4. We're going to have to use power of powers there. And then that's going to be x to the 4. So if we power of powers that, we multiply them. So we get 2 to the 4. And in this case, we're going to actually write it out. So that would be 16 m12 x to the 4. Okay, so if we practice, we're going to do all of them. So for question 7, we're going to take that 2 as an exponent and distribute it onto all of them. So we'll get 7 squared x to the 5 squared, which would be x to the 10, and 7 squared to be 49. And then we'd have y to the 4th squared, so that'd be y to the 8. Question 8, distributing. Again, we're going to have to be careful because we have a negative 4. So it's going to be negative 4 to the 3, which happens to give us negative 64. X squared cubed. We multiply those, so that gives us x6. Y to the 3 gives us y9. Next, we're going to have to square every part. And I'm going to pretend that that's a -1. It's just going to be easier for me to think of it that way, but you don't have to do that. So I would think of this as -1 squared, which is +1, and then m squared, which is m to the 4. So I could just write m to the power of 4. Both would be correct. It's just one's a little more accepted. Question 10. We're going to have to follow BEDMAS. Follow BEDMAS, which means we're going to do the exponent first. We're going to distribute that exponent first. And the 2 only goes onto the term that it's attached to, okay? So only distribute exponent onto term it is attached to. So we'll leave the first term in its brackets, -3xy, and then we're going to have -2 squared, x squared, y squared. So that gives us -3xy times -2 squared is 4, and then x squared, y squared. And now we'll do number times number. -3 times 4 gives us -12. X times x squared gives us x to the 3. Y times y squared gives us y to the 3. And last, we're going to do exponents first. So that we're going to square all parts of the first term. So it's going to equal 10 squared a squared b squared c squared times -2a squared b c. That gives me 100 a squared b squared c squared times -2a squared b c. We're going to multiply now, because remember, squish together really is multiply. So number times number, 100 times -2 is -200. A squared times a squared is a to the 4. B squared times b is b to the 3. C squared times c is c to the 3. And that's it. We are done lesson 2.2. 2. Thanks for watching.